Welcome to Narayan online bridge course classes. Hello students. So yesterday we completed some of the concepts on how to find out the number of protons, electrons and neutrons. So in this today's episode we will discuss how to find out the molecular weight of the compounds. Molecular weight of the compounds or molecular weight of the substances we have to find out. What is molecular weight? Or how can you find out molecular weights of the substances? Molecular weight is sum of the atomic masses of all the elements in a molecule. Okay, it is sum of all the elements. It is sum of all the elements present in a molecule is called as a molecular weight of the substance only. So what is required for to calculate the molecular weight means we have to know each and every atomic weight perfectly. Yesterday we discussed the elements atomic weight from 1 to 31. Okay. Suppose let us take a small example H2O. Let us see one example. We have water. So what is the molecular formula of the water? We have H2O. We have to find out the molecular weight of water. According to the definition, what we have, it is the sum of all the, it is the sum of atomic weights. It is sum of atomic weights of, it is sum of atomic weights of all the elements present in a molecule. So we have the water molecule from the H2O. Here we have two hydrogen atoms are there and one oxygen atom is there. How can you find out this molecular weight? Okay, we have two hydrogens plus one oxygen we have. You know already weight of hydrogen is 1 and weight of oxygen is how much? 16. So 2 plus 16, how much we have? 80. Okay, what is the gram molecular weight of water? The gram molecular weight of water is how much here? 80 gram. Let us take one more example. We have NaCl. What is NaCl? NaCl is sodium chloride. Sodium chloride. Okay, sodium chloride we have two ions are there. One is Na plus ion and one is Cl minus ion. What is the molecular weight of NaCl? Molecular weight of NaCl is equal to, okay, how many sodiums you have? One sodium atom and one chloride atom, that is Cl. If you want to know what is the atomic weight of sodium, that is how much? 23. And what is the atomic weight of chlorine, that is 35.5. How much we have? 58.5 moment. So what is the molecular weight of NaCl? NaCl molecular weight is how much? 58.5 volume. Let us see one more example. We have NaOH. NaOH. What is NaOH? NaOH is a sodium hydroxide. Sodium hydroxide. Sodium hydroxide is an acid or base. It is a base only. Why? It gives OH minus ions in the solution only. Okay. For us, we have to find out molecular weight of NaOH. Okay. Molecular weight of NaOH. How many sodiums we have? One sodium, one oxygen, and one hydrogen. So I am writing here 1 into Na plus, 1 into O plus, and 1 into what? Hydrogen. So sodium how much we have? 23 is the atomic weight. Oxygen how much we have? 16. And hydrogen how much we have? 1. So total how much we have? 41. What is the molecular weight of NaOH means 40 is the answer. Now let us see one more example. We have Na2CO3. What is Na2CO3? Na2CO3 is sodium carbonate. Sodium carbonate. How many sodiums we have? Simply I am writing here. Molecular weight is equal to 2 into Na plus 1 carbon plus 3 oxygen atoms. So in the formula what we given, sodiums are 2, carbon is 1, oxygens are how much? 3 only. Here sodium atomic weight how much? 23 plus carbon atomic weight how much? 12 plus 3 into 16 is the atomic weight of oxygen we have. This is 46 plus 12. How much? 48. So 48 plus 12 we have 60. 60 plus 40 is how much here? 106 is the molecular weight of which one? Sodium carbonate. Let us see one more example. A simple example. HCl. HCl you can say hydrogen chloride or you can say hydrochloric acid also. Okay. So HCl molecular weight, suppose you can find so 1 into hydrogen plus 1 into chlorine. This is 1 plus 35.5. Total we have 36.5. This is a gram molecular weight of which one? HCl. This is what? Molecular weight of sodium carbonate how much? 106 solid. So like this we have to find out the molecular weight of the different types of the compounds. So generally we can use directly the formulas in the calculation part. For that we have to know how to find out the molecular weight of any type of the molecule or any type of the substance. You have to perfect in atomic weights of the elements. Now let us see some other examples on the calculation of molecular weight of the compounds we have. One is H2SO4 here. What is H2SO4 name? H2SO4 we are calling as a sulfuric acid. Sulfuric acid. So the sulfuric acid is called as a king of acids. Generally, we want to find out the molecular weight of the sulfuric acid. So directly I am writing here 2 hydrogens plus 1 sulfur plus 4 oxygens we have. So 2 hydrogens in the sense here 2 into 1 2 plus this is 1 into you will write it sulfur how much? 32 we have. This is 4 into 16 we have. Clear? So 2 plus 32 plus this is 64. Total you will get 4 plus 2 6 6 plus 2 8 6 plus 3 9 98. What is the gram molecular weight of H2SO4 means 98 is the answer. Clear? Next you can see HNO3. What is HNO3 name? HNO3 name is nitric acid. What is the name of the compound? Nitric acid. How many atoms are there? 1 hydrogen, 1 nitrogen and 3 oxygens. So 1 hydrogen plus 1 nitrogen plus 3 oxygens we have. 1 into 1 plus what is the atomic weight of nitrogen? 14 plus 3 into we have 16. 1 plus 14 plus 48. What is the weight of this compound means 63 is the atomic molecular weight of which one? Nitric acid. Okay, this is 48, 49 and 63. Now we can see the next we have CH3COOH. What is the CH3COOH name we are calling as a acetic acid. Clear? Acetic acid also we are calling as vinegar only. Vinegar means the concentration of acetic acid will be less. Clear? In acetic acid, how many atoms we have? Carbon is there, hydrogen is there, carbon common here, and oxygen is there, and hydrogen is there. From this I am writing here this formula C2H4O. 2 carbons we have, 3 plus 1 4 hydrogens and 2 oxygens. So clear? Now we can multiply 2 carbon plus 4 hydrogen plus two oxygens only. This is a 2 into 12 we have, and it is 4 into 1 we have. This is a 2 into 16 we have. Clear? So this is how much, man? This is 24 plus 4 plus 13, 2 only. 2 plus 4, okay. Here 4 plus 4, 8. So 8 plus 2 we have 0. And how much you will get? 60 is the molecular weight of this one. Acidic acid. What is the other name of acidic acid? That you can say vinegar also. Now you can see another example. We have KCl. What is KCl full name? Potassium chloride. Potassium chloride. How many potassiums we have? Only one potassium, means one potassium ion, one chloride ion. I am writing here 1 into K plus 1 into Cl. Potassium weight is 39. Okay, that is into 1 plus. Chlorine weight is 35.51. Now we will get 39 plus 35.5. So we have 39 and 35.5. So 9 plus 1, 14 here. How much we have? 74.5 is the atomic weight or molecular weight of which one? Potassium chloride. So this is the way we have to find. Okay, we can see the remaining example here. CH3OH, methyl alcohol. C2H5OH, methyl alcohol. KMnO4, potassium permanganate. ZnSO4, zinc sulfate. Al2SO4 taken 3 times. This is aluminium sulfate. CaCO3, this is calcium carbonate. MgSO4, magnesium sulfate. Okay, this is C6H12O6, that is what? Glucose. C12H22O11, this is what? Sucrose. So same method you can follow and can find out what is the gram molecular weight of all these compounds. Just this is taken one exercise, you can complete it, then you will get more clarity how to find out the molecular weight of any of the compound. So that molecular weight of the element compounds you can find it. Okay, and the next concept we have valency bond. What is meant by valency? Valency is a combining capacity of an element. Simple definition we have. Valency is what? Combining. Valency is combining capacity of an element. Means the element can combine with how many different other elements on. Simple definition. Clear? So the combining capacity of an element is called as valency. So generally if you want to write the valency, this we have to take the reference elements like hydrogen, oxygen and chlorine. Clear? I am writing here hydrogen, chlorine and oxygen. By taking these three elements, you can define valency also. The number of hydrogen atoms or number of chlorine atoms or double the number of oxygen atoms with which one atom of an element combines is called valency. The number of hydrogen atoms or number of chlorine atoms or double the number of oxygen atoms with which one atom of an element combines is also called as valency bond. That you can define like this also. Let us see one example by taking these three reference elements we have. Hydrogen and here chlorine and here oxygen. Just I take the elements here sodium, magnesium and aluminium. Clear? So sodium and hydrogen, they will combine to form sodium hydride. Sodium and chlorine, they will combine to form sodium chloride. Sodium and oxygen, they will combine to form sodium oxide. Okay, let us just get on to draw one table for this one. Let us, we can write it by combination with all these elements. Clear? Hydrogen is there. Central hydrogen. What is the definition I told? The number of hydrogens or number of chlorines or double the number of oxygen atoms only. So sodium and hydrogen. Sodium generally belongs to first group element only. It valency 1. We'll discuss again. Its valency is 1. Sodium and hydrogen will combine to form sodium hydride, that is NaHO. Clear? Sodium and magnesium combine to form sodium chloride. Yes, sodium and oxygen combine to form sodium oxide, that is Na2O. Why? We want to take double the number of oxygen atoms only. Clear? Now magnesium. Generally magnesium belongs to second group in the periodic table. Its valency how much means its valency is 2. Sodium valence, suppose what you can write here 1 only. Magnesium valence is 2 and aluminium valence is how much? 3 only. Hydrogen valence is 1, Cl valence is 1, oxygen valence is 2 only. Clear? Now magnesium will combine with hydrogen. Magnesium will combine with hydrogen. It will form magnesium hydride, MgH2 only. MgH2. Magnesium will combine with chlorine. It will form MgCl2. Magnesium chloride will have. So magnesium will combine with oxygen. It will form MgO, that is magnesium oxide. You may get some confusion. Why we have to get only MgO here? Why? Magnesium valence is 2. Oxygen valence also 2. Okay. Then both are used the formula which one? MgO. Now we can see aluminium valence is 3, hydrogen valence how much I told? 1 only. So it will form AlH3. It will form AlCl3. It will form Al2O3. Al2O3. Clear? So sodium hydride, magnesium hydride, aluminium hydride. Sodium chloride, magnesium chloride, aluminium chloride. Sodium oxide, magnesium oxide, aluminium oxide are we calling as aluminium oxide. Clear? Now, how can you write these formulas like this means we have to use one method. That method we are calling as a Criss-Cross Method. What method, man? Criss-Cross Method. We will discuss how to write the chemical formulas by using this Criss-Cross Method. Clear? Just you can recall that periodic properties already is there in your SSLC syllabus and the periodic classification of elements only. In that periodic classification of elements, you can see the groups and periods in the periodic table only. Let us concentrate on the groups we have. Generally, we are calling as 1 to 8 groups. We are calling. Okay, then 1 to 8 groups elements. What are they? What is its valency? We will discuss now. Clear? So we can see the first group elements we have. So we have 18 groups are there. Okay, sometimes we are calling as 1 to 8 groups also. Group elements is there. If you want to take the first group we have. Okay, if you want to take the first group elements we have. What are the first group elements we have? Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. If these elements you can observe here, what is the valence of all these elements means the valence of all these elements is 1. Come to this second group we have. Okay, second group elements you can take this one: beryllium, magnesium, calcium, strontium, barium and radium. The valence of the second group elements is 2. Come to this we have third group we have. Third group we can take this one. Okay, boron, aluminium, gallium, indium and thallium. What is the valence of these elements means 3 only. If you want to take this one, fourth group elements. Fourth group elements we have carbon, silicon, germanium, tin and lead. What is the valence of these elements means 4. Clear? Means in the periodic table from group 1 to group 4, valency is equal to its group number. Valency how much? Group number. First group valency 1, second group valency 2, third group valency 3 and fourth group valence is what? 4 only. From this what you can write here? Valency is equal to its group number. Valence is equal to what? Its group number. Here. Now we can see from 5th group to 8th group. From 5th to 8th group we have. From 5th to 8th group I will write valency is equal to 8 minus group number. Valence is equal to what? 8 minus group number, particularly for which elements? 5th group to 8th group elements. So, what are the 5th group elements we have? Okay, what are the 5th group elements we have? Nitrogen, phosphorus, arsenic, antimony, and bismuth only. Okay, what are the formula I told? 8 minus group number. Here 8 minus 5. 8 minus 5, that is equal to what? 3 is the valency for which group? 5th group only. Let us come to we have 6th group elements we have. Okay, oxygen, sulfur, selenium, tellurium, and polonium. 8 minus 6 we have, that is equal to 2 is the group number. Now come to we have 7th group elements we have. 7th group elements we have fluorine, chlorine, bromine, iodine, and astatine. Okay. Here, from these elements you can write here 8 minus 7, that is equal to what? 1. Here, if you want to take 8th group elements, generally 8th group elements we have all the noble gases, so helium, or you can say from argon, krypton, argon, neon, argon, krypton, xenon, and radon. For these elements, you will write 8 minus 8. That means what? 0. Means they cannot combine with any of the element. Particularly which element? Those are noble gases. Here one exception is there. That is with xenon. Clear? So our intention is you have to know what is the valency of each element in the periodic table, particularly on the groups, first group, second group, third group, up to 8th group. You have to know. First group valence, what I told, from group elements from 1 to 4, valency is equal to what? It's group number. From 5th group to 8th group, valency is equal to 8 minus group number. Means first group valency 1, second group valency 2, third group valency 3, fourth group valency 4, fifth group valency 3, sixth group valency 2, seventh group valency 1, and eighth group valence how much? 0. So if you know this concept, it is very easy to write that. Okay, chemical formula by using the Criss-Cross method. So next concept is Criss-Cross method. What is the use of this Criss-Cross method? Means we have to write the chemical formula by using these elements valency formula. Here, Criss-Cross method is used to write the chemical formula of a compound by using the valencies of the given elements only. Okay, let us see one example we have. Okay, what is the use of this one? To write which one? Chemical formula. Criss-Cross method may be used for the writing of which one? Chemical formulas of the elements. So let us see one example here. Here A element is given and B element is there. Let us imagine valency of A is 1 and the valency of B is 2. Clear? 1 and 2 is what? 1 and 2 is the valencies of A and B elements. Okay. Just you can cross multiply this element valencies. Okay. Cross multiply elements valencies. A is 1 and B is 2. If you want to multiply this like this, what you will get? This is A to B is a chemical formula of the compounds. Clear? Suppose just I am interchanging the valences like this. A A2 and B1 like this one. What you will get here? You will get AB2. A, B2. Here valencies are given. Sometimes they will give charges also. Okay, how they will give charges here? Suppose A is some +3 and B is some -2 is given like this. Okay, not only we are using valency, not only we are using valencies to write the chemical formula of the compound. Sometimes we have to use the charges also. The charges may be give positive charge or what not, negative charge only. Here, what are the charges given? A plus B. Here what the charge is given? B -2 only. So neglect the charges, we can write the same quotient here. Here you will write what? 3. And what you will write here? 2 only. Just you can do the cross multiplication. Then what you will get? A2 and B3. Okay, charges are given. You can do this one. Same. You can neglect the charges, whether it is a positive charge or negative charge, and you can write this formula. This method very helpful to write the chemical formula of the compounds. Let us see one example here. The example given like this. Suppose I am taking here sodium and chlorine. Sodium I am taking here Na and Cl I am taking on. Already we discussed sodium belongs to first group element, chlorine belongs to 7th group element. So first group element valence how much means that is 1. Second group valence how much means 7th group valence how much, that is also what? 1 only. You can do the cross multiplication, then what you will get? You will get which one? NaCl. What is the name of this NaCl? Sodium chloride. Sodium chloride. Let us see one more example we have. I am writing here magnesium and chloride. Magnesium valency 2. Why 2? It belongs to second group elements. Its valency 2. And chlorine belongs to seventh group elements. Its valency 1. Then you can do the cross multiplication. Then what you will get? MgCl2. MgCl2. Third one you can take here. I'm taking one example here. Aluminium and chlorine. Aluminium is the third group element, its valency 3. Chlorine is the seventh group element, its valency is 1. Then you can see this cross multiplication. Then what you will get here? AlCl3. So this is what I'm taking only the valences of the elements only. If the charges are given like this, okay. Suppose the charges are given like this only. For the charges I am writing here, H plus is given, H plus and SO4 2 minus is given. H plus hydrogen ion, or you can say H hydrogen ion only. And SO4 minus 2, this is a sulfate ion only. Plus means what are the charge we have? You can imagine this is a plus 1 only. Here I am writing here H2 and here what? SO4 only. What are the valence? What are the charges given? Plus 1. We can take here 1. Here SO4, what are the charges given? 2. I am writing here 2 only. Then we can say what are the compound we will get? H2SO4 only. H2SO4. This is for ions only. Okay. Suppose the ion is given like this. Suppose the ion is given like this. Ca2 plus and PO4 minus 3. Ca2 plus calcium ion, PO4 minus 3, that is phosphate ion, and you can take here calcium and PO4 here 2 and here how much? 3 only. Okay, so this is 2 and this is 3. Do the cross multiplication, you will get Ca3PO4 again 2 times. This is what? Calcium phosphate formula 1. So like this, if the charges are given, you can write like this. If the valences are given, you write like this. So this is mainly what method I am telling? Criss-Cross Method. It is very useful to write a chemical formula of any of the compound. Let us see this table. We have different negative ions are there. What the other name of negative ions means? Anions. And one column we have positive ions are there. Those what we are calling cations also. Here Cl minus chloride. CO3 minus 2 carbonate, OH minus hydroxide ion, SO4 minus 2 sulfate ion, PO4 minus 3 phosphate ion, NO3 minus nitrate ion. Clear? So by using this table we have to write the each formula of the different combinations. So like Criss-Cross Method, what I told, sodium and chlorine, each charge is plus 1 minus 1. You neglect the charges, then what you will get? NaClO. Clear? Na and CO3 minus 2. Suppose I am writing for understanding here. Na is there, CO3 minus is there. Here 1, here 2. Then what you will get? Na2CO3. Na2CO3. And OH minus we have. OH minus is there. Here what? Na plus OH minus here 1 and here 1. What you will get? This is NaOH, sodium hydroxide. So let us see this next example. We have SO4 minus 2. SO4 minus 2. Na charge is 1, SO4 minus means the charge is 2. Then what you will get? Na2SO4 you will get. Na2SO4. Next what we have? PO4 minus 3. And here Na plus, and here we have PO4 minus 3, here 1 and here 3. Then what you will get? Na3PO4. Na3PO4, sodium phosphate. And that's one example, NO3 minus, that what you can say here? Na and NO3 minus, here plus, here minus 1, here 1 and here 1. Then what you will get? NaNO3. Okay? Like this you can find this table. Okay? The same manner you will get chlorides, carbonates, hydroxides, sulfates, phosphates and nitrates.